The idea of optimizing HVAC DDC systems is not a new one, but what we have done in the past can always be improved on. Why? Why would we optimize? Well, cost savings would be this first reason. Energy savings, reduced carbon footprint, improve comfort for your occupants, which in turn will improve the productivity of your organization. In this video, I'll review quickly some optimization tips. I won't go into much detail. Obviously, each one has its own story. And then at the end, I'll have two that I'll go into depth with. Okay, tip 1. Damper and valve exercise programs. Simple program to open and close actuators 0 to 100% if they have not done so in a given amount of time. This would reduce labor, maintenance, and add life to the equipment. Maintaining building envelope pressure. This will also reduce your building energy consumption. DDC calendar point. On the island we have created 20-year stat holiday calendars for clients. This is very productive labor-wise and ensures savings are made on setbacks on every stat holiday in the future. Demand control ventilation. Saves energy by reducing overventilation. You would use CO2 sensors, your dampers, and VSD drives. Reduce nuisance alarms. This will improve productivity. Alarming and monitoring of critical equipment will then be the focus. Also consider remote alarming capabilities to emails and cell phones. Supply air reset calculation. Measuring and resetting the supply air temperature effectively can create cost savings. Finding the best calculation to suit the building and the client is key. Optimal start. It's not unusual for stop-start schedules to fall out of adjustment. One of the common failures is a complaint is made from the building occupant and then an operator creates a weekly schedule change to start the system early. The change is not put back and now the system runs at this state 365 days a year. No one is to call and complain that the system is starting too early. This is basically a seasonal adjustment done on a weekly schedule when the correct way is to have a proper optimum start. Back in November 2007, I was involved in a recommissioning of a small elementary school in Nanaimo school district called Brecken Elementary. The school had weekly schedules starting at 5:30 to 6. We added optimum start and set the weekly schedules to start at 8 and 8:30. This reduced the overall runtime of the equipment and also reduced the amount of fresh air coming into the building during unoccupied times. The school had 5 main fan systems. We then allowed the building to operate and later requested data for the gas and electrical consumption. We were given the data from 2002 to 2011. Using this data, I placed the yearly totals in an Excel file and found the following. Okay, we took all the data that we received and we accumulated the yearly electrical consumption, the cost, and the gas. We came up with a 5-year average and we compared that to a 3-year average of those 3 totals, and we came up with these totals, and that was our percentage of reduction. And our percentage reduction in cost is 15% compared the 5 years to the 3 years, and the gas consumption reduction was 13%. Now you notice that these aren't the same, and the reason being is because the electricity was cheaper in these years than it was in that year, and there was no demand charge for the school for these, I believe it was these 2 years. So that was the difference. Okay, after doing the first analysis, numbers are funny things, so we decided to do another analysis. The first one was a 5 to 3 year analysis, and this is a 4 to 2 year analysis. Reason being we did this is because in the final year, in 2010 and 11, they did a lighting retrofit. So we took that year out and we just calculated the 2 years after we did the DDC work, compared to 4 years prior to the DDC work. We took out the very first year because it had a very high number. And so our values here are 90% reduction, 13 and 16% reduction compared to the other calculation, which was 25, 15 and 13. Still saving money, still making the building work better. Okay, I'm not tied to a system because this building has a modem and I didn't have a modem to do this demo. But basically, my next optimization, or even kind of a green thing, is if you have a system with a chilled water system that shuts down in the winter time, and when your chiller is off, you could run this pump and use it to reclaim heat. And how you would do that is the pump would run. This loop basically becomes stagnant at nighttime and raises up to 21, 24 degrees. So there's some capacity of heat in that loop. You turn it on and you could send that heat to your fan system. And as long as your heating coil was off, you could actually use that heat. You could bring in more fresh air into the building and allow that fresh air to hit your coil. That fresh air, if it was, as long as it's colder than the actual water temperature, a few degrees, you'll basically gain some heat off of this. Then again, you'll be sending cold water back down, and if the system on your floor plates is requiring any cooling, these fan coils would turn on their cooling coil valves and take that cold air, which is sitting at between 17 14 degrees, and they would heat it back up and send it back up to the air handler, and the air handler would resume it. It's only certain times of the day that you can do this, but it does utilize your cooling system when it's down as a heat reclaim system. Things you can do this in the hospital is reclaim heat off of an MRI system, throw it into the chilled water loop, and use chilled water systems on fresh air devices. Now the only problem with that is having the cooling coil behind the reheat coil, behind the heating coil. But there's cases where you can use that, and I've done that in 2 hospitals.